Shrewd Manager Christianity's Position. 1988's radiocarbon dating tells us how the shroud was made more than when. Part 1. In 1988, 3 labs radiocarbon dated cuttings from a single swatch of the Turin Shroud. The average result appears to support a medieval date. But is the evidence sufficient to overcome all the indications the shroud wrapped Jesus? 2 writings, a paper and a letter, published in the 1989 issue of Nature, still frame the debate over the shroud's age and its authenticity. The paper, Radiocarbon Dating of the Shroud of Turin, reports that laboratories in Arizona, Oxford, and Zurich dated samples using the AMS method. The results provide conclusive evidence that the linen of the Shroud of Turin is medieval. There are good reasons to accept this. Leading labs using state-of-the-art methods all returned a medieval date. Control samples matched their known ages. By the late 1980s, AMS was new but validated against tree ring chronologies and other cross-dating techniques. And the paper reported detailed results, error margins, and statistical analysis. But there are also strong reasons to question the study. Agreed protocols were abandoned. 7 labs became 3. Multiple sample sites became 1. 2 methods became 1. And the cloth was recognizable, so the tests were not blind. Oddities included mismatched sample weights, the British Museum refused to release the raw data, and years before the cutting, archaeologist William Meacham warned against choosing samples from edges and high-handling areas. He was ignored. So should we accept or reject the paper's bottom line? 10 years after publication in Nature, a new perspective emerged that helps us decide. Studies show the test results should not be combined. They are heterogeneous. This means the fabric tests as if the samples came from different pieces of cloth having different dates. To illustrate, if a basketball player scores 90 points over 6 games, that's 15 a game. But if he only played 3 of those, it's 30. You can't average games played with games sat. They're heterogeneous. Not even Michael Jordan scored from the bench. But this is just statistics, not real world, right? Well, no. The real world requires statistics. From weather forecasts, medical advice, and search engines, to traffic apps and quantifying risks, such as flying versus driving. It's not merely academic. Bottom line, the study's case rests on grouping the lab's statistics, but such grouping is statistically invalid, so we can't pool the results. But that doesn't mean we throw them out. Heterogeneous data are not garbage. We just need to work it another way. For our basketball player, if he played all 6 games, including the 3 he scored 0, we'd look at each game separately. Maybe he was double-teamed, or played through an injury, or was told to focus on defense. It's the same with the radiocarbon dating. Later studies stratified the results by lab, comparing them individually. Before 2017, this was limited by lack of raw data, until researcher Tristan Casabianca won their release. Since then, at least 4 peer-reviewed papers have analyzed the data, confirming earlier evidence of heterogeneity. Breaking it down by lab, Zurich's tests average about 75 years younger than Oxford's 3, but both are consistent within their error bars. The real conflict is Arizona. Turin failed to cut 3 equal pieces, so Arizona got 2 smaller, non-adjacent samples. Their dates spread by 200 years, well past the margin of error, showing Arizona's results cannot be collapsed into a single age. Further, as with the invalid grouping of all 4 pieces into one date range, Arizona and Zurich are heterogeneous, making their grouping invalid too. This is all very odd. All the subsamples were cut on the same day from the same small sample, only 70 by 10 millimeters. For the metrically challenged, that's about 2 3/4 inches by 3/8 of an inch. Samples from such a small area should not test like different cloths. Now for a plot twist. All 4 peer-reviewed studies independently found the variations weren't random scatter, but depend on location. Each detected directional, spatial trends the clearest being that samples closer to the shroud's interior tested younger than those closer to the edges. Some students of the shroud suggest contamination or repairs explain these dating anomalies. While these factors may contribute, neither is sufficient. Contamination fails because controls match known ages, which validates AMS and the lab's cleaning processes, and contamination cannot account for a 1,300-year gap. Repair theories also fail since they require younger at the edges, but multiple researchers found the opposite. The letter published in Nature guides our next video. Harvard physicist T.J. Phillips proposed that neutron irradiation of the linen could boost its C14 content, making the shroud test younger than its true age. He offered a plausible mechanism that could reconcile its traditional antiquity with the anomalous date. Notably, Phillips predicted that uneven neutron flux from the body would create carbon-14 variations across the shroud, phenomena later discovered and confirmed. Anticipating evidence years in advance is the mark of a strong thesis. Nuclear physicist Robert Rucker spent 9 years modeling Phillips' insight. As we'll see, Rucker's model not only accounts for the observed heterogeneity and the younger toward the center trend, but also points to image formation. In sum, the single date range is invalid. That leaves two options: dismiss the individual lab results or accept them. If we dismiss them, they say nothing about age. If we accept them, their inconsistencies point more to how the image formed than when the cloth was woven. Despite the small data set, we lean towards acceptance. Next, the neutron irradiation model and its coherence with other observations.